Today we're going to learn about functions. So what's a function? So function, we're going to consider something very easy like this equation here. Okay, so we're going to fill out this information. So when x is 1, we're going to find out the y value. So we substitute 1 into x. So 2 times 1 minus 1, what would that give you? That will give you 1. Okay, and how about the second one? 2 times 2 minus 1, that will give you 3. And if you substitute 3, you get 2 times 3 minus 1. That gives you 6 minus 1, 5. Okay, pretty easy, isn't it? So, and then we're going to introduce a new notation like called fx. So what does that mean? It means that if I replace the x by 1, I'm going to change the x here to 1. So write 2 times 1, which is exactly the same thing, but except that now the two values are connected. So instead of saying x equal to 1, y equal to 1 separately, I write them as one statement. Okay, so let's look at the next one. All right, f2 is 2 times 2 minus 1. That gives you 3, right? And then finally, f3, you will just get 5. Okay, does that make sense? So it connects the x value with the y value with one statement. Okay, let me write this clearly. Okay, all right, so we've got this, and then we've got this. Okay, so write f3. All right, good. Okay, let's move on. So what is a function? Basically, a function, let me use a red pen. A function is simply any rule that maps the x value to the y value. We call the x value input. We'll put the y value output. Okay, so basically, these are the input, okay, and these are the output. Okay, good, like that. And what else I'm going to say? And we say the rule f is a function. So the function f maps the x value to the y value. That's what the f do. We call f the function. So it maps the x value to the y value. Okay, maps x to y. So that's what a function is. And more specifically, we call this. We met this formula in the linear relationship topic, right? So therefore, this function is called the linear function. Okay, linear function. All right. So now we know what a function is. Let's have a more formal definition of a function. Okay, good. Let's move on to the next column. So what's a function? So any ordered pairs is called a relation. A relation in which each x value produces only one y value is called a function, and can use the function notation. Graphically, any relation that passes through the vertical line test is called a function. Any vertical line drawn through a function will cut it only once. So let's look at this formula. So we got this y equal to x squared plus 1. So this is a parabola. So we put some dots. Put 1 there, you get 3. And then you get this point. And we'll get a parabola. And then I think 2 is 5. Okay, so we'll get this parabola. Okay, good. So you can see for each x value, there's only one y value, right? For each x, there's only one y. So we say this is a function. Okay, and it satisfies the vertical line test. Vertical line test. So we draw lots of vertical lines. Right, you only cross the graph only once. Okay, crosses graph only once. Okay, like that. All right. So we call this function a quadratic function because it's x squared. So we call this a quadratic function. Okay. All right, good. All right, what else I'm going to say? I think that's all. Actually, sorry, I forgot. I actually left some space here. Quadratic function. We call the above function quadratic function. Okay, actually, I could just drop this off. All right. Okay, good. Okay, all right, that's it. So copy it down. Any questions? So we looked at how a function is. A function is simply that maps each x value to a y value. That's what a function is. I think that's it. Okay, let's go to the next page. Okay, we'll go to the next example. Okay, let's look at this order pair. So let's plot these points. So 1, 4 is here, 1, 4 for a dot here, 2, 4 is over there, and 4, 5 is here, and 5, 3 is here. Okay, so we got 4 points, and as you can see, it satisfies the vertical line test because each x value is only one y value, right? Each x, one y. Okay, so we say this is a function. Okay, so remember, each x only one y. Yep. Oh, this one there's no. Well, the function, the rule is not clear, right? There's no formula, so it's just a list of points. Yeah. Yeah. Yeah, so that's a function because it satisfies the vertical line test. Each x value. Oh, so it's not asking you for the formula for the function. It's just saying whether it's a function or not. Yeah, you're right. All right, good. So you just have to say whether it's a function. What formula for the function is not required. Okay, next. Let's look at the next one. Is this a function? No, because it fails the vertical line test. It crosses twice. Okay, so no. So if it's not a function, we call that a relation. Okay, good. Okay, so now we know how to identify whether something is a function. We're now going to do some questions. And the questions are quite simple. We've seen how the function relation works. Actually, I should write something here. Fails the vertical line test. Okay, because it crosses twice. Oh, I need to go up? Okay, all right. I'll make it bigger. All right, write it down. Okay. All right, let's move on to the next question. Yep. Crosses the graphs. So see, this line crosses the graph twice, whereas these lines only cross the graph once. 2 points of intersection. So if I draw a line here, crosses twice. Vertical line. And why is it not okay? Because when x is 0, so when x is 0, y is 1, or when x is 0, it could be y negative 1. So it's not a function because one x value gives you 2 different y values. That's why not a function. Each x only gives you one y. That's why we have the vertical line test. Does that make sense? So that's why if the vertical line test crosses more than once, each x value does not correspond to exactly one y value. In this case, it corresponds to 2 different y values. Okay, let's move on. So we'll go to the next question. So let's look at this. Okay, I'll look at this formula here. So that's a quadratic function. So we're going to calculate f of 0. So f0 equals to 0 squared minus 3 times 0 plus 1, which is equal to 1. Yep. How about negative 3? Same things. F of negative 3 equals to negative 3 squared minus 3 negative 3 plus 1. Okay, equals to, now when you square the negative, it becomes positive 9. Negative 3 times negative 3 is positive 9 again, plus 1, so your answer will be 19. Okay, Alright, so the values you substitute are not limited to numbers. It can be polynomial. So in that case, you just go FC is C squared minus 3C. So basically, whatever you substitute into the bracket, you replace the X by the thing inside the bracket. And of course, it's not limited to one term. It could be two terms, like A plus 1, right? So what that means is every time you see an X, replace it by A plus 1. And there is another X, replace it by A plus 1. Okay? And then you go plus 1 here. Alright, any questions? All good? Alright, continuing on. Now you need to use algebra to expand. So let's expand the perfect square. So you get A squared plus 2A plus 1 minus 3A minus 3. It's a very long chapter. Yeah, a very important one too. Okay, and then you're going to collect like terms. So this 2A and negative 3A are like terms, so you get negative A. And then if you add the rest, you get A squared in front. And then you got, what else are there? 2 minus 3, you get minus 1. Hopefully you got that answer. Okay, cool. So now we know how the function notation works. We also have to study more terminology. Okay, go to the next page. Alright, next page, let's do another question. Let's look at this. Okay, so the next question we're going to ask is, what are the possible input a function can accept? What are the possible output you could have? So to answer this question, we're going to look at this simple example again. We substitute x equal to 1, what's the y value? 2 minus 1, you get 1. When you substitute 2, you get 4 minus 1, you get 3. And then when you substitute 3, what do you get? You get 5. Or you can substitute negative 10, or you just make up any values. What would that be? That would be minus 21, and if you substitute say 1,000, what's y value going to be? 2,000 minus 1, 199. Okay, so the question is, what are the possible input you could have? What sort of numbers you can substitute? You can substitute anything, isn't it? You can substitute anything. Well, not anything, any real numbers. Okay, so these are the possible input, and then let's look at the output. So that's the input, and then you have the output. What are the possible output you could have? Oh, it looks like you could have the output could be negative, the output could be positive, output could be anything, isn't it? So we'll say the output could be any real values too. Any real values. Okay. So there are names for this. The set of all input and the set of all output, they are special names. The names are called domain. So the set of all permissible x coordinate is called the domain. So the domain in this case, actually we're going to fill it out at the bottom. So that's the domain, all the x values, and all the y values is called the range. These are the range. Okay, range and domain. Okay, so let's answer this question. So for this function, we can say the domain is all real x, all real values of x, all real x, and the range is all real y. Okay, so pretty easy, isn't it? So for this function, maps any x value to any y values. Okay, all right. Of course, that's an easy one. Let's look at something a little bit more complicated. Yep. Yeah, so in year 12, if you are doing extension 2, you have what we call complex numbers like this. So anything that doesn't have a square root of a negative number, we call them real numbers. And the real numbers includes 1, 3, or root 2, or pi, -3, fraction, etc. These are called real numbers. And we call the number line the real axis. Okay, the real axis. All right, so let's drop this. Actually, we'll keep it there. All right, so let's look at the next bit. Okay, good. Let's look at this. G of x, so the function notation not limited to f, I could call it g as well. So g of x is x squared. Let's substitute negative 2 in. What do you get? Negative 2 squared, we get 4. Yep. Negative 1 squared, I get 1. 0 squared, I get 0. 1 squared, I get 1. And 2 squared, I get 4. Yes? So the question is, what are the domain and the range? If you look at this, I could substitute any numbers, isn't it? So all real x is allowed. All real x. Now, how about the output? What are the possible output it could be? Can the output be negative? No. So in that case, the range will be y bigger than 0, right? You expect this function can only give you a positive output, not negative output. So we can summarize it below. So for the domain, you will say all real x, whereas the range will be y bigger than or equal to 0. Okay, so that's the domain, that's the range. All right, any question? Now, before we go to the next page, I still want to say something about it. So basically, if I were to draw this graph, so I'm going to draw this graph here, and you know what the graph look like. The graph look like this. So that's the graph, and we're going to draw the parabola, right? So you may wonder, why is it called domain? Domain is, if you look at it, the x-axis, domain is when you walk on the x-axis, you can always see the graph, isn't it? No matter where you walk. That's why it's called the domain. When you're walking on the x-axis, you can always see the graph. It's all real x. On the other hand, if you got the range, let me use a green one, the range, you have to look at the y-axis. You can see the graph when the y values are positive. Because if you go below negative, if you go below 0, you can't see anything, right? Can't see anything. So that's why the range is on the y-axis. Okay. All right. Let's look at this on another example. So we're going to look at this question here. Example 3. Okay. So write the possible x and y values for these functions. So we got this graph here. Watching. So we substitute the x value in, which is negative 5. Put 0 will be negative 1. And then you get 3, right? Now, clearly, I could substitute any x value. So we say the domain is all real x. Like that. And if you were to draw this graph, let's try to draw it. So negative 1 is negative 5. 0 is negative 1. 1 is 3. And then I'm going to use the line drawing tool. I'm going to connect this. Actually, I think I could draw it now. Okay, let's try to draw it. Okay, so we've got this line. Okay, so we've got this line, and we can see for each x value, there's only one y value, isn't it? Right? And you can see from the graph, the domain is all real x. And if you look at the graph, what's the range? Range is, I could see the graph here, I could see the graph, I could see the graph. I could see the graph anywhere I choose on the y-axis, isn't it? So we say the range is all real y, because all y values are possible. Okay, we've got this one. Let's try the next one, parabola. Okay, so how do I do the parabola? So the parabola, if you substitute some values, you'll get negative 1, you get negative 3, you get negative 4, you get negative 3 again, right? So what's the domain again? Let's draw the graph. So negative 1, negative 3, and then got these 3 dots. Now I think crosses to 2. Now I'll draw this. All right, so we'll draw this graph. Okay, good. So that's a parabola. So we're going to look at the domain. So domain is anywhere you walk on the x-axis, you can see the graph. So we say domain is all real x. right? How about the range? What are the possible y values it could be? Yeah, y has to be more than 4, right? More than -4. I could see the graph. So y is greater than or equal to -4, but not below, right? In here, I can't see anything. Right? So these are the range. Y bigger than -4. Okay, now we're going to finish off. We're going to move on to do find the domain range of some more complicated function without even drawing. Okay, so let's look at the next bit. Hopefully you're all ready. Okay, good. Let's move on. Next page, next column. All right, let's look at this. Okay, as you can see, the function notation are not limited to letters. It could be a word like fun, right? You can call the function fun. Fun of x is root x. So if I go fun, say 4, it means square root of 4. And fun 4 means 2. Okay, so you can name it anything. I just said that. So just saying this is a rule, I could just substitute a number to see what that answer is. Okay, so now can we do fun of -4? Is that allowed? We can't, okay? So already we can see there's some restriction on the domain. So what would the domain be? X has to be positive values, right? Yeah, that's the domain. The domain is x greater than or equal to 0. So you can't substitute any numbers. Sorry. All right. Okay. So you can't substitute any numbers. So you can only substitute positive numbers. How about the next one called cool? Okay, let's look at what cool do. Cool. Now look at cool. You can substitute -4 now, right? No problem, because if I substitute -4, I get 1, right? Which is allowed, right? Which is 1. But can I substitute any negative? What if I substitute negative, say, 10? Would that be allowed? That would be not acceptable. So it's not all negative values, only some negative values. So what would the domain be? Well, the domain is not -4. You can also substitute -5. Yeah, so what I do is, whatever that's inside the square root, I write x plus 5 bigger than 0, and we solve for x. Subtract both sides by -5, you get x bigger than -5. That's your domain. All right, got it? So when you see a square root, whatever is inside has to be positive. Okay, good. All right, next one. How about the second one? LA. All right, let's do L of 3. Gives you 1/3, right? No problem. You can do -3. That's no problem. Are there any numbers you can't substitute? 0, right? Because when you do L of 0, we'll get 1/0. Is 1/0 allowed? It's not allowed. If you do on a calculator, do 1/0, mode 1/0, you get undefined. Okay, so you get undefined. So the only thing you can't substitute is 0. So we say the domain will be all real x, anything except x equal to 0. So when you have a polynomial in the denominator, you can't substitute 0. Everything else is okay. All right, and then let's look at the next function, call it m of x. M of x. So now m can accept 0, right? Because now okay, right? 3/-4. That's okay. You can't have 4, yeah. So what you do is to find the domain of this, whatever that is. So it just extract the denominator. So just write x minus 4 cannot be 0. Means x cannot be 4. Okay. So that's what you do. You have polynomial in the denominator. So you say all real x except x equal to 4. Okay, good, like that. All done. 2 more questions, then we're done. Okay, how about the next one? How would you find the domain for that? Now we know you just have to right circle this. 4x plus 1 cannot be 0. And that's a little bit more complicated. Means 4x cannot be, this off, not 1/4, 9 minus 1/4. Yeah, minus 1. So x cannot be -1/4. So we say all real x except x equal to -1/4. That's the domain. So once you know the domain, I know what input it can accept. So we will avoid all the input it doesn't accept. Okay. All right. Good. The last one. What would you do? This one's a little bit can be a bit tricky, but see if you can see it. What would you do? What are the restrictions? Yep, Damien. No. No. So you go 4 minus 5x. Remember, it has a square root. What's the restriction? Has to be positive, but it cannot be 0, right? Because if it's here, it can be 0, but if it's in the denominator, it cannot be 0. Does that make sense? So then we solve. So that means we get -5x is bigger than -4. X will be less than -4 over -5, means that x will be less than 4 over 5. That's your domain. All done. So hopefully now you see what a function is. Function has domain and range. We'll have the function notation, and we'll know what a function is. So make sure you start exercise. What exercise is this? Exercise 9H today. All right, so you can start now. Thank you.
Oh, yeah.